Hi, this is me, Thuruvan. This is my demonstration for RIS 602 Lab 1. In this lab, we have reviewed Chapter 1 and 2 of the Art of Network Pen Testing book. So this is the agenda for this demonstration. First, we'll go to the introduction, where in the Chapter 1, the author what why he justifies why pen testing is important for corporate environment and the four phases of pen testing. And then he talks about the book is based on his own capsule core project. So the what kind of environment we have to build to test the tools and everything based on the book. And then in chapter 2 he dives into the first phase of the pen testing, which is the information gathering. And there we have to discover the live host. And then and at last we'll go through like a live demo of my network with the tools and everything, and then we'll do some extra exercise which was not on the book. In the fourth chapter, the author explains why a penetration testing is important for a corporate. So when a data breach happens to a corporate, it causes a big financial and reputation damage. So they have to know what are the vulnerabilities in their environment and how can an attacker get into your system. So pen testing is most of the companies do it for a year, or it depends on the company size and everything. So they have most of the time they hire a third party to do the pen testing. But nowadays, big companies have their own pen testing team. So they will think like an external attacker and try to find a vulnerability in the system to get inside, and then figure out what they can do with that vulnerability. And then they will inform the company about it, and then they will patch. This is how the pen testing works. So they have to think and act like a real attacker and find the weaknesses they can find in the environment to exploit them. And these are the four phases of the internal network penetration test. So what is meant by internal network penetration means like attacker, which means like in a corporate network, there can be an external attacker who, like, let's say there's a Google company and we are the external users for their company. So we don't have any knowledge of the internal system or anything. So we are like externally trying to find a vulnerability like that. But normally the corporates do the internal network penetration test, which is like they will give the attacker they are inside their network. So the pen tester will be inside their network. They will just give them a possible network range, which their systems are, and then the pen tester will start exploiting the things. So the first phase is information gathering, where the pen tester will figure out the number of live hosts in the environment in the network, and then check for what are the services running, and then find the vulnerabilities in each of the services and find any unpatched vulnerabilities where the attacker can get into their system. And the phase two focus penetration is like where actual hacking begins. So after they figure out the vulnerabilities, they'll try to exploit the vulnerabilities and then try to hack into the system. And the third phase is post exploitation and privilege escalation, where they will make a backdoor for their vulnerable machine so that they can go back into that machine whatever the time wants, just like the attacker. And then they will figure out and store all the credentials they can figure out inside the system so that they can use it whenever they want. And then let's say they have a normal machine and they move to another machine from that machine to try to get an admin access at the end. And phase four is the important phase where you will gather evidence at each of the phase and then have screenshots and everything, and then create a proper document where it has to be like readable even by a non-technical person. So in this lab environment, so I'm using a Kali Linux VM, even though the author suggests Ubuntu VM, as he's saying like Kali Linux VM may be overloaded with the pen testing tools because most of the Kali VMs are preloaded with the pen testing tools. So, but I feels like Kali Linux works better in this type of things. And that capsule core enterprise network, which he explained in the appendix C. So I followed the same network and the services he said in the appendix C, and then created the my own environment with his instruction. So this is phase one. So phase one is like identifying the live system within the scope. But you should know what are the scope, what your engagement scope is. Let's say they give you an network address, so you have to figure out the live host in that network. But you have to inform them before you start exploiting them because they should approve the like these are the hosts you can do the pen testing because some of the machine they have it for like serious level work, so you shouldn't touch them. And then some of them maybe like a honeypot they have to fake it so that to divert the attacker if it really happens. So the author says we should have a targets.txt and then ignore.txt file where the uh, approved systems should be on the target.txt file. The IP, just the IP has to be there. So we can use it on the Nmap or any other tools, just specifying the text file. And then in the ignore.txt file, we should ignore those hosts in the pen testing. So usually the host to figure out the live host, we use ICMP, which is like a we see in this diagram, the PC1 says, can you hear me? And then PC2 says, yes, I can hear you. So that PC1 knows the PC2 is alive. So this, which means it's a live host. So we in this book, he in the chapter 2, he works with most of the Nmap commands with ICMP. And then in my additional exercises, I have explained how we can figure out the live hosts without ICMP. Let's say if the firewall is blocking the ICMP, what are the other ways you can get to know about the live host? So the other do some performance tuning to make the Nmap scanning faster. So by default, Nmap scans each of, let's say we give a network range, let's say it has 256 maximum host, and then the Nmap divides that into four, like at same time, it will do the pinging or like the scanning with just for 64 hosts. That's their default size. So we can change the minimum host group into 256. So at single time, it can do 256 hosts. This way, we can improve the time for the Nmap scanning. The minimum rate 1280. It's like to increase the packet speed. Which can like drastically reduce the Nmap scanning, but it may be sometimes make issues like um, it may not be able to scan properly. The scan results wouldn't be 100% accurate like that. So we just need to be careful with that. So this is the additional exercise I have designed to configure like the local network to drop all the ICMP packets, even though the ping sweep is the one which checks for the pinging, and then pinging results, it will show how many hosts are alive. So I have disabled the ICMP in the attacker VM. So in the outgoing traffic, I dropped all the ICMP packets. So when you do pinging, normally it wouldn't work. So the ping sweep doesn't work with the Nmap or everything. And then I used three different scanning, which was not on the book to figure out the live host in the network. So in this exercise, I'm gonna do disk ARP scanning. So ARP is a layer 2 protocol scanning. So ARP request sends out to figure out the MAC address or like an IP address of a network. So in layer 2 network, they don't need to know about the IP address to get to know a host is alive, ping can only be done by an IP address. So in this way, we are sharing ARP request. So this way, even if the ping is blocked by their machines, the ARP request still went through and then figured out and then it gave us 100% success. And the next one is UDP scanning. So this way, UDP sends some random packets to like an closed ports on all the machines and all in all the network range. So if it will wait for the port unreachable error message. So if the nmap gets that error message from specific IP, it means that IP is up, the machine is up. So we this is how the nmap figure out with UDP the a host is alive. And this the last one, TCP acknowledgement scanning. So in the, you know that in TCP three-way handshake, there's there are one. Let's say we have two hosts A and B, and one host sends the sync packet, and then the receiver send back with sync plus acknowledgement packet, and the last sender sends again the acknowledgement packet. So the three-way handshake is done, and then their connection is established. So right now, this nmap will just send an acknowledgement packet, which is the last stage of the three-way handshake. So when the acknowledgement packet is sent to the machine, the machine thinks it checks for any existing connection with the receiver. So it wouldn't find any existing connection, so it will say no, or it will send back a reset packet. So the nmap get tracks of it, the reset packets from which IPs they are getting the reset packet, and then those IPs are the one who's alive. If the user has a stateless firewall, so it doesn't know any TCP connection or established connection is already enabled, then it will send through the acknowledgement packet. If they have a stateful connection, then they will track the connection and they know the acknowledgement packet is coming from some random IP which doesn't have any prior connection, so they will block. So this is the conclusion. So we have to approach the discovery of the host in a structured way to prevent missing data or any missing host or to prevent false positive. So in the firewall rules, even if the ICMP is blocked, we can figure out whether the host is alive or not. So that's my additional exercises are doing. So this is the lab network right now we have for the follow the book, The Art of Network Pen Testing. So here you can see I have all the VMs ready and running. And this is my pen testing VM, which is the Kali VMs, and I already have the directories as specified in the book. I'll just do a tree, and then you can see discovery and then host. These are the files I got after I got the map scanning done. This is the ranges.txt. This is the range we're gonna do the scanning. So before that, I'll show you, I'll follow the book. So I'll just show you IP-A. So there we can see the IP address of the Kali machine and the subnet mask /24, which means 256 hosts in this IP range. So that's what I have in the range. I'll show you. Yep, you can see there it's the subnet which where this Kali machine resides. And then after that, we can do a simple ping sweep using the bash without you before using the nmap. We'll just follow the book exercise first. So he's doing the bash to run repetitive ping commands and then see whether the host is alive or not. So I'm just looking at the book and then I'm doing it. So this is the command we need to do. So what the command is like for 1 to 254. So here you can see octet. So this is the variable. So we are giving the value for 1 to 254 and then do ping just one time. Just send one ping request to this network 10.0.10 dot the octet. So it's gonna switch values from 1 to 254 and then see what are the machines that are alive, and then save that in the pingsweep.txt file. Or I'm using the and at the end so that this command runs in the background, not in the terminal. So I just press enter. It says done, and then I'll just do pingsweep.txt, and then I'll use the grep command just to show the live host. So this is here we can see 200, 201, all the 9 machines which is running right now. And then let's move into the nmap command. I have the book on my other screen. And from this, we can just copy these IPs to their target.txt. I'll just show you. Give me a second. Okay. Here, these are the network. Sorry, these are the hosts which we have to do the pen testing. These are the machines which are running there. Then let's just go to the nmap command. He specified the first simple command. So what this command does, it's just doing a discovery of the host using the nmap just with the ping key. Okay, first is the password. So here we specify dash sn, which blocks the port scanning, just the ping scan. So it will take a bit because it has to go through all the ranges, all the 56 hosts, and then check which are alive and not, which are not. So here we could see these things. It says 12 host up. Then we can use this command on. So when we do the nmap, here we specify here. So as you can see, we have saving those results in tree map. So we'll do tree, and then you can see ping sweep dot XML nmap and gnmap. So this XML file can be used in different tools. So this file contains the live host. So we can use the same file on different machines to run, sorry, different on different tools to run the scanning and everything. So these three formats will be always be saved when we use those command. Sorry. So here you can see these are the hosts which are up right now. So in the book, he uses the remote management interface port. So usually all the machines you will have like someone to access those machines remotely by an admin or someone else. So all the servers, let's say a web server is running, they're not gonna come to that machine and then work on it. They're gonna run a remote machine. They're gonna have access them remotely. So some of the common remote access ports are like as specified in the book, the 22 SSH host that's usually uses in the Linux machines network, and then 2222 also used for the SSH, and then RDP, which is like for the Windows machine to use the Windows machine computer remotely. It's TCP port number 3389, and then HTTP and HTTPS 80 and 443 ports. So we can do that scanning. Like Nmap will not send a ping or any traffic. It will send a port traffic to that specific ports and then see if they are up or not, if they are open or not. So this command will just the command. So we just run this. So here we have using the performance tuning. So as I have explained earlier, this command is gonna run faster and give us results faster. Just give me a second. Yep, it just takes 3 seconds. Usually it takes more time, and then we use the performance thing, so it just comes faster. So we can see in this machine 209 only SSH is open, and we could see here some other ports are open. Here HTTP is open like that. Mm, then yeah, and then he explained about the Nmap scan to protect to scan a large subnet. Let's say instead of /24, let's say the subnet is /8, which means there are 2 to the power 24 host is available. So it's with the Nmap, it's not like it's possible, but it's going to take a lot of time to scan all the hosts. So the author explained an idea to do like a scanning just for the node dot one. Usually all the networks have that as a gateway, or some other machines they usually have that IP. So if we are good enough, we could figure out like what are the IP network ranges they are running. So here you can see so that let's say they give you 10.0.0.0/8 network. So you have to figure out how the host and everything. So first of all, we have to figure out how many network subnets in that range. So we have to figure out how many subnets are there. So here he specifies 0 to 255, and then here on the third octet 20 to 255, and in the fourth one he just specifies one. Let's say 10.0.0.1. So that could be a gateway, or there's a live host on that IP. We don't know, but most of the times they use as the dot one. So and we just increase the performance and it will get the results faster. But all of them say fail to determine the route to the network because we only have route to this network. So from this interface, they don't have route to any of the network here we have mentioned. So everything just failed. It's just a testing from the root. So let's just move on to the things we did, like I did about the boot level. So this the ARP scanning. Before that, I'll just apply the firewall rules that blocks the scanning. So before that, I'll do a scanning so you can see the scan being succeeded. And then I'll do so instead of block going to the each of machine and then block the ping, I'm just gonna block the outgoing ping from the Kali machines. It's, that's applied, and then I'll do the ping again. You can see it's gonna fail. So we don't need to waste time here. It's going to take a while to get the fail thing. So this is the ARP scanning. I'll just do the scan and then let's see. Sorry. We can also open Wireshark to pull. I'll do the scanning again. So you can see a lot of ARP checks whether this IP, if anyone has this IP. This is how the ARP scanning works. And then boom, it just figured out all the IPs. Yep, it took 20 seconds, but it got all the IPs, all the live hosts just using the app. So even though the thing is failing, now let's do this. The one TCP acknowledgement packet thing. So it's gonna send some TCP acknowledgement packet, and then it's gonna check whether host alive. So still now the ping is blocked. So let's see. we use this dash dash send dash IP to send only the IP, not the ARP request, because when it's blocked, the Nmap default gonna use the ARP request. So we use this option to just forceful the Nmap to use IPs, not the ARP. So as you can see here, we got this thing. It shows these are the live hosts, and then finally we do the UDP scanning. So it will send an empty UDP packet to the closed ports on all machines. If the machine says it's not reachable, like a reply, then the Nmap considers it as a live host. So we could get the replies, and we could say it says 11 host up in 23 seconds. So I would say this knowledge is enough to figure out the live host in a network. And that's it. Thank you for watching.